I don't like it when it does that. Okay, so now we're doing the last part of rational functions, which is how do you solve rational equations? And these dates are wrong. So we're going to have our quiz today, and then we'll have review day Tuesday and Wednesday. Remember, Monday's another holiday because we need more time off, you know. And then Thursday and Friday will be the test, and then Monday and Tuesday are normal school days before exams are the next Wednesday, Thursday, Friday. And then you get another day off for the semester, right? I think you get the Monday, whatever that is, 27th to 30th off. Okay. So like I said, we're in good shape. How about your other classes? Were they okay with losing time? Were they scrambling to come up with a plan? Okay, so there's going to be two different ways that we address this here, right? If you have a rational equation, which is essentially just one fraction equals another, which is called a proportion, right? Then we'll have one method to solve. If we have an equation which is actually not that, it could be more complex even than this, but like one fraction equals the sum of two other fractions, that's a totally different kind of a problem. I mean, how do you think we're going to end up solving something like that? Right? So if ever you've just got a fraction equals a fraction, cross multiplies, that's when you use cross multiply. I mean, you get a lot of students will take something even like this when they just haven't seen it for a while, and they'll just think, oh, do I cross multiply or will I multiply? No. The only time you ever cross multiply is when you've got a fraction equals a fraction. That's when you cross multiply. I mean, ultimately, these always end up with variables in the denominator, and we need to get the variables out of the denominator so we can solve for them, right? It's going to end up being x equals, you know, and there's your answer. So we need to get them out. So cross multiplying is the quickest way to just get it out of the denominator. Okay, so if it is a proportion, a fraction equals a fraction, then we're going to cross multiply and then solve whatever is left. And it could be linear, which means you can use pretty much algebra 1 techniques on that, or it could be a quadratic. I mean, it could even be a cubic. Not likely to be, but I think we've got one in here which does end up being a cubic. Okay, and then we've got to do something that's similar but not exactly the same that we've done before, which is check for extraneous solutions. What did it mean to say to check for extraneous solutions before? Yeah, you would find a solution that when you plugged it into the original equation, it didn't work. And so you would say, okay, that means it's not a solution. It's the same word, but it's not exactly the same thing. Now we're going to plug it in the original equation and see whether it leads to a divide by zero. If the original equation ends up having like a zero for a denominator, when you plug in one of your answers, that's extraneous. I mean, evidently, that clearly doesn't work either, but you're not going to get to a point where if you plug it in and you don't have divide by zeros where there's an extraneous solution. The only time to get extraneous is because it led to a divide by zero. But it's still that same word, extraneous. Okay. So, first one, right? So this is a proportion. It's a fraction equals a fraction. So I am going to solve by cross multiply, right? So make sure we all know how to cross multiply, right? That should be 3 times 4x plus 5 equals 9 times x plus 1. Right? You multiply the numerator of one fraction times the denominator of the other. Right? Now, we don't have any more denominators, so this is actually not a rational equation anymore. So we solve, it's linear, just 12x plus 15 equals 9x plus 9. Okay, let's get the x's together, minus 9x, 3x plus 15 equals 9. To subtract 15, 3x equals negative 6. So x equals negative 2. Okay, now check. If I plug in a 2 here or here, does it lead to a divide by 0? Right? If x equals 2, that denominator is 3. If x equals 2 here, right, the denominator is 13. So no, neither one leads to a divide. So that's okay. That's okay. So the answer is x equals negative 2. No extraneous solutions. So those are the steps, right? Cross multiply, solve, check. So try that one. Cross multiply, should get x equals negative 3. Is negative 3 going to lead to any divide by zeros? No, so that's the answer, x equals negative 3. Good on that one? I think I got another one. Try that one. So, when you do this, they're not always linear. Could be quadratic. Then you got to remember, how do we solve quadratic equations? And most of the time it involves getting everything on one side, 0 on the other. I saw most of the ones I saw, you had you moved it to the opposite side, so you had negative 2x squared plus 6x plus 8. Not wrong, but usually when you're thinking of factoring, it's probably easier to have a leading coefficient which is positive. So you either multiply by negative 1 or just get things to the other side in the first place. And then every one of these was divisible by 2, so just divide out a 2. Remember, you could do that because it's an equation. And they got 0 on the other side, so just divide it by 2. And then that is easily factorable. X minus 4 times x plus 1. So these are the answers. Does either one of these lead to a divide by 0? I mean, you could actually look at this equation at the very beginning and say, look, the only possible extraneous solutions are the zeros of the denominator. So negative 5 halves, negative 8 11. So if you don't get those as your answers, then you don't have any extraneous solutions. Okay, here's the second kind. How do you solve when it's not just one fraction equals another? So you can't necessarily cross multiply. Well, if you're really in love with cross multiplication, you can definitely add the fractions on one side so that it is a proportion, and then cross multiply and solve. That's method 1. That'll be the first thing we try out. Pretty good. Okay, so for example, in this one, let's add the two fractions on the right side so that it's one fraction equals another. What would be the LCD for these two? For x, right? Got to have every factor that you see in either denominator, and they're pretty simple. So what do I multiply the first fraction by so that it has that denominator? How about 4 over 4? And the second one? X over x. Okay, so by doing that now, I've got 9 over x equals 7x plus 20 divided by 4x. Okay, now cross multiply. So this is going to be 9 times 4x equals x times 7x plus 20. So we've got 36x equals 7x squared plus 20x. Okay. So what kind of equation is this going to be? It's quadratic. So we need to get everything on one side, 0 on the other. Subtract 36x from one side, 7x squared minus 16x. Is it factorable? Yes, it is factorable. What kind of factoring? It's the greatest common factor, right? What is the common factor between those two? Take out an x. So 7x minus 16. So x equals, okay, what's the solution if you have one factor was just x? 0. And then from 7x minus 16, 16 over 7, right? 16 divided by 7, the 7's cancel, 16 minus 16. Okay, check them. So again, the check is against this equation, 9 over x equals 5 over x plus 7/4. Any extraneous? Yeah, that 0 is extraneous, right? Because if you plug that in here, you get 0, or here. So extraneous. Okay, so the only answer is 16 over 7. Okay. So try to do the same thing with that. Should have been negative 6, right? The least common denominator was 2x, right? Because of 2 and x. So this one you multiply by x over x, the first one, the second one by 2 over 2, which should have given you 7x plus 6 over 2x equals 3. And you don't even, it's not really even cross multiplication, just multiply both sides times 2x, and there you get it. Okay, next, possible. Okay, now this is a me try, not a you try. You're probably looking at that going, oh my gosh, that looks terrible. That's so bad. Okay, so let's see. The first thing we got to do, if we're going to have to find a least common denominator for these two terms, then we need to factor the second, or this fraction right here. So this is going to be 6 over x minus 3 equals 8x squared divided by x plus 3 times x minus 3. That was wrong. And then we're going to go minus 4x divided by x plus 3. Okay, now what's the LCD for these two terms right here? Yeah, x plus 3 times x minus 3. Okay, now the first fraction's okay. That's actually its denominator already. But the second one I need to multiply by 4x minus 3. Okay, now I can add that up. Right, this is going to be 8x squared minus 4x squared plus 12x divided by x plus 3 times x minus 3. Okay, now I'm going to simplify. This is 6 over x minus 3 equals, and I'm actually going to simplify this by doing this is 4x squared plus 12x. And the denominator, for multiplying purposes, I'm just going to say that again as x squared minus 9. So we just added the two fractions on the one side. So now we have a proportion, and now we can cross multiply. So we do that. Right, 6 times x squared minus 9 equals x minus 3 times 4x squared plus 12x. Okay, so 6x squared minus 54 equals, now we've got to FOIL that bit right there. That's going to be 4x to the third. Let's see, minus 12x squared minus 36x. No, I'm missing something. 4x squared minus 12x plus 12x squared minus 36x. Okay. Which I can simplify. 6x squared minus 54 equals 4x to the third. The 12x squareds cancel. So I've got minus 36x. Okay, now I'm going to go this way. Get everything on one side, 0 on the other. This is going to be 4x to the third minus 6x squared minus 36x minus 54, no, plus 54 equals 0. So this is actually a cubic. So how did we learn to solve a cubic equation? Say again? Yeah, I mean, when we didn't have many ways to solve something like this. I mean, this is the kind where you might like graph it and look for a 0 and try to divide out a 0, but we're not going to do that. Remember, if you have 4 terms, you might look and see whether grouping looks like it would work. And if it's going to work, then it should be, for example, if negative 6 divided by 4 should be the same as 54 over negative 36. So is it? I mean, you could put in the calculator, what's negative 6 over 4? Okay, what's 54 over negative 36? It's the same thing, right? So grouping is going to work here. It wouldn't always work, but these problems are usually kind of carefully constructed, you know, to make it work. So grouping will work in this case. So we will group the first two. And this time, because I've got this minus in front of the parentheses, I've got to be careful, right? That'll be 36x minus 54 equals 0. And then I have to group each set of parentheses, right? Factor each set of parentheses. That'll give me 2x squared. That's going this way. 2x squared times 2x minus 3. And the next one we can factor out an 18. And that'll give me 2x minus 3. So that'll give me, go this way, 2x squared minus 18 times 2x minus 3 equals 0. Okay, but we're still not done. Because 2x squared minus 18, what's the common factor? 2. And what's left when you factor it out? X squared minus 9, which is the difference of squares. So just to jump to the conclusion, that's 2 times x plus 3 times x minus 3 times 2x minus 3 equals 0. That's completely factored. Okay, now what does that make the solutions here? X equals negative 3, x equals 3. And then from this factor, 3 halves. Right. So there's the 3 answers. Now, let me go back and forth. What if I try to plug those into the original equation? Do any of them lead to divide by zeros? In fact, 2 of them do. Negative 3 and 3 are going to lead to divide by zeros. So we have to say that both of these, right, both of these are extraneous. So extraneous. So the only answer is 3 halves. That's the answer. Now that's a lot of work for one problem. The thing is that leads us into method 2. Method 2 is the one that you don't get as many extraneous, and it's maybe less work to do, and it's also kind of similar to what we did in part of the homework from last night. So in this case, we're going to find the LCD, much like we did with the complex fractions. Find the LCD for both sides of the equation, and then multiply both sides by the LCD. Right? We're not trying to find a common denominator for both sides. We're not trying to find a common denominator for both sides. We're just saying find what it would be, and then multiply both sides by that, because it will then cancel all the denominators, and you don't have any rational expressions anymore. It's not a rational equation anymore. So you just solve what's left, check your answers. Okay, so now here's the same problem, but we'll do it this other way. And you'll probably think it's easier if we do it this way. Okay, so let's see, the LCD, and I'm going to show this a little different, right? So we've already done this. Let me do it like this. 6, oh, edit, undo. Edit, undo. Blue. So we have 6 over x minus 3 equals 8x squared divided by x plus 3 times x minus 3 minus 4x divided by x plus 3. Okay, the LCD is going to be the same thing, x plus 3 times x minus 3. So, but that's still, this is the LCD for the whole equation, both sides. Okay, now we're going to multiply both sides by that LCD, x plus 3 times x minus 3. And just like we were doing in the homework last night with the complex fractions, you know, when you multiply that times this one, the x minus 3 cancels, and you'll still have 6 times x plus 3. When you multiply this term by that, both of those will cancel, and you just have 8x squared. And when you multiply this one, the x plus 3's will cancel, and you'll just have 4x times x minus 3. So in one step, no more denominators. So this is going to give us 6 times x plus 3 equals 8x squared minus 4x times x minus 3. Okay, simplify. 6x plus 18 equals 8x squared minus 4x squared minus 12x plus 12x. Okay, that's going to be quadratic. 6x plus 18 equals 4x squared plus 12x. So now we'll get everything on one side. That'll be 4x squared plus 6x minus 18. Okay, now we can divide through by 2. 0 equals 2x squared plus 3x. Oops, that was wrong. And minus 9. And then can we factor that? 2 times negative 9 is negative 18. Are there factors of negative 18 that add up to 3? Yeah, positive 6 and negative 3. So you could go through the long process, or you could just try to guess and check. I'm going to guess and check because I don't want to take up that much room. All right, so I'm going to say this is 0 equals. You know, I know that the first factors, the first term in each parentheses is 2x and x for sure. That's how I get 2x squared. Now 9 could either be 1 times 9 or 3 times 3. We could play around with it, but I'm pretty sure we're going to get something like, how about 2 times positive 3 and 1 times negative 3. I think that'll work. No, that's wrong. I meant to say something different. Minus 3. Let's see if that works. 2x squared, negative 9. Okay, the middle term will be 6x minus 3x, which is 3x. So that's good. So what are the answers? X equals 3 halves and negative 3. The last time we got 3 answers. This time we only got 2. But one of those is obviously still extraneous. So we got to take that one out. Right, this one, extraneous. So the only answer is that, 3 halves. So that was method 2. Yeah. Did I have that wrong? Probably. 2x squared. No, because it was 12x minus 6x. Yeah, I already had to say that was gonna. So there's just another method. You know, in the end, you could do these problems any way you want. I would probably do it like this. But so I think you got one more you try, and then we're done. right? So the LCD was pretty easy, right? 2 times x minus 1. Multiply everything times that. You should have gotten, in that one step, right? Get rid of all the denominators. 3 times x minus 1 is that. Plus 4 times 2, because the x minus 1 cancel. It equals 2 times x plus 1. And then it's just it's a linear equation. Distribute, combine my terms. X equals -3. Definitely not going to lead to any extraneous solution. So that's the whole thing. So that is the lesson. And that is the homework.